In today's Daily Dose of Math, I'm going to make orthogonal projections of this stack of dice. I'm going to do 5 different views: front, back, left, right, and top. There is also, of course, a bottom view that's possible, but I'm not going to do that. And I'll talk about that more when I get to the top view. What I've done here with these dice is I took advantage of the fact that they have numbers on them with dots by putting all of the 6s facing the front. The 2s are facing up and the 4s are facing the left. If you know your dice, you know that means that the 1s are facing the back, the 3s are facing the right, and the 5s are facing the bottom. This is just to help stay organized as we figure out what our front, left, back, right, and top projections will look like. Now, you are never likely to be asked for all 5 of these, or all 6. What's most common is a front view, a top view, and a side view. The side view could be the left or the right. And the reason for that becomes apparent when we look at the different projections. Let's get started with the front view. I took a photograph of what the dice look like from the front. Remember, the 6s are in the front. And we can see a little bit of the detail of the stack of dice from this front view, but there are some details that are hidden from us. When I draw my orthogonal projection, I'll use squares for each of the cubes in the dice, and I'm not going to put little dots for numbers on them. So I start with 5 squares in a row, from left to right. My mouse is making this a little bit sloppy, but I'm able to make a view that looks like I want, or sort of. And I need another 2 squares up on top over here on the right. Okay, so it sort of looks like that. Now the left view is where the 4s are, and it looks like this. So when I draw it with my squares, I need to put 4 squares in a row, and it looks like this. Now the back view looks a lot like the front view, but where the tall tower of 3 dice is of course reversed. It's over on the left side now. Not too surprising what we get. Now we're starting to see the reason why when we're asked for orthogonal projection, we're not asked for all 5 of these. We're not likely to be asked for both the front and the back, because as you can see, they don't look that different. Let's do the right view. Now finally, let's look at the top view. This is the one where we're seeing the 2s on the dice. And it looks quite different from the front, back, or left, right. And that helps us to see how useful it is to have the top view included in our orthogonal projections. Now, the interesting thing about the top view compared to the others, when we look at front, back, left, and right, in all cases we know which side is down. So we only have one possible front view, one possible back, one possible left, one possible right. But with top view, we have more than one possible view. I'll show you what I mean. I could spin this around like that, and it's still a top view. It's still a correct view. I could spin it around like this, and it's still a top view. Because there is no bottom to be concerned with, we could see it from the top from various different directions. But I'll stick with my original top view as the one that I'll hand in for this assignment. Now the take-home message here is we get to see why it's useful to have 3 views: a top, a front, and either a left or a right. Because when you take those 3 views, it's showing you everything that you need to see about the stack of dice so that you could figure out anything else that would be revealed by other views. That's why 3 views is enough. This is an example of orthogonal projection. It is today's Daily Dose of Math. Please like, subscribe, and share.